All right, section 4.3 in your textbook, page 213. We're looking at equation solving strategies. So the goal of this section is to solve equations where variables appear on both sides of the equality. So we haven't really seen that too much so far. We've dealt a lot with the variable either being on the right-hand side of the equation or on the left-hand side of the equation. Today we're trying to solve, again, only one variable, but this time it happens to be on both sides of the equation. Okay, so let's look at that. So the question reads, who'd like to read it? Michael, go ahead. Atish?
I think.
Calvin? Atish?
Atish and Sarah are playing a game on the computers. The goal of the game is to be the first to figure out which input will make the two machines generate the same output. They have input several values. Here are
Three ways, okay, and we've already touched upon them in the last two sections, even going back to chapter 3. There's a table of values, which is this. How do you think we can answer this by using a table of values? I've already kind of done it. I've already estimated, but how could we answer it? Michael?
Just find a number between 2 and 4.
Yeah, so you would want to input a number between 2 and 4.
Yeah.
Right? So you would, in this particular example, put into the machine, you would say input 3, check result. Okay, we don't have that information because obviously we don't have the machines here. So the best we can do with the table of values method is to just say we can estimate at this point. We're going to estimate. Put it over here. So estimate of 3 based on our current knowledge. All right. The next thing we could do is what? It's right there, but what do you explain it to me, somebody? Yeah, Michael again? Graph?
Yeah, you graph it.
Okay, so
So
how would we graph it?
You would have the independent value being the input
Okay,
on the bottom on the horizontal axis, and then
very good.
have the output information for both machines. So I think you would have to do 2 graphs.
You wouldn't do 2 graphs. You're right. You'd have 2 sets of data,
Yeah,
but you do what?
You would have 2 lines.
Yeah, exactly. So you do 2. So you plot this data twice, right? So this would be like. So just like you said, you'd have the input here, because it's independent, the output, which is dependent, and then you plot the points for the first set of data points, and then you plot the points for the second set of data points. Okay, let's say it's that. And then this is, let's say, machine 1. And this is machine 2. Okay? And where do you think the answer would be then? What would be the same output? How would I figure out the answer? Carlson?
Where the lines meet.
Exactly. So right where they cross, right there, that input will give me the same output. Okay, and we know it's going to be somewhere in between 2 and 4. Okay, so with a graph, if we have a relatively accurate graphing paper, we'll get a pretty good idea. So I would say in this scenario, the graph's better because we can actually graph it based on the data that we have here and get pretty accurate. But of course, there's another way, which I prefer. It's the equation. It'll give us the exact answer. Who can tell me how we might do this with an equation? Mark, what do you think? How do we figure out the equation? Not sure?
Oh, you sub in the independent and the dependent values for M and B.
Okay, M and B, M is not an independent or dependent value, it's a slope. And B is not either of those either, it's a y-intercept, right? Santos?
So you put the input for x.
The input, okay, we could sub in an input for x, but in actual, what will be the most useful for us is if we can figure out the equation for each one. okay, the equation of the line. If we know these two equations, right, y equals mx plus b and y equals mx plus b, then we can set the y value the same. So we have an equality. We'll say the y is equal, and then from there we can solve. So we need to find the slope for the first table, all right? So that's why I added this column here, first differences. The reason I added that is because we know for slope, if we want to find the slope for machine number 1, what's the formula for slope? Jesse?
y2 minus y1 over x2 minus
Okay, so we have the formula. That's for both machine 1 and machine 2. So Ryan, what's the slope for machine 1?
1.
Good, so we're going to do 1.75 minus 0.75. Over 2 minus 0. So he said 1, but it looks like in actual reality it's a half. Okay? And that's understandable because typically we move up by 1 in the input column. In this case, we're moving up by 2. That's why we do need to divide it by 2. Okay? So the first slope for machine 1 is 1 half. What's the y value for machine 1? Andrea?
Pardon me, I'm sorry. Mr. Aquino, please contact the office. Mr. Aquino.
Austin, what's the y value?
0.75.
How'd you know?
Because when x is 0, y is 0.75.
That's it. Not hard, right? X is 0. What's the y-intercept? They already told us, 0.75. Okay? So we know b is 0.75. So now, with those two pieces of information, we can do our line, our equation for our line, which is y equals mx plus b. So it's going to be y equals, m is 1/2, x plus b. Okay? All right, Jacob, you're going to help us with the next one. So what's the equation for slope, Jacob?
Rise over run.
Good. So rise over run, which is what?
Y2 minus y1 over x2 minus x1.
Which is what for machine 2? Does it matter, Jacob, if we pick this is y2 and this is y1, or this is y2 and this is y1? Doesn't matter, right? Any points. Okay, so give me one value of y for the second machine.
1.5.
Okay, 1.5, good. And what's y1?
0.5.
Good. Not positive 0.5, but negative 0.5, right?
Yeah.
Right? Because it comes from here. So what are the corresponding x values for those y values you just gave me? So in other words, what is x2? Right, and x1?
0.
Very good. But I could have used these two, right? I could have done 5.5 minus 3.5 is 2. 6 minus 4 is 2. So here we're going to find out 1.5 minus 0.5 is plus 0.5. So what we actually end up with is 2 over 2, which is 1. All right, we got our slope. Josh in the back is going to tell us how to get our y-intercept for machine 2.
For machine 2? Although y-intercept for machine 2 is 0.5, or negative 0.5.
Very good. Negative 0.5. Good. So now our equation, Sanchetti, is what? What's our equation for number 2, machine 2? Take your time. So the slope is here, and the y-intercept is here. Okay? And here's our general equation, right? Y equals mx plus b. So what's our equation now?
Y equals 1x plus 0.5.
No, not plus.
Oh,
Minus 0.5. Okay? And I don't need to put that 1 in, right? We don't have to say 1x. It's just a notion.
You see how the formulas y equals mx plus b?
Yeah?
It's like, so you don't need to put the plus if there's a negative, right?
Here?
Yeah. Like
Plus negative? No, it's just negative.
So instead of writing like,
Plus
Yeah.
minus 0.5, just write minus 0.5.
alright,
Any other questions? All right, so we have this equation for machine 2, and we have this equation for machine 1. So now David's going to tell us what might we do next if we want to find out the input to get the same output. This is probably the hardest part of this question, yeah?
You would plot both on the same graph.
So you could do that, yeah, we mentioned about doing that. Well, we could have done that just with the ordered pairs, right? We could have just plotted this point, and then this point, and then drew the line anyways. So you're right, that's one way, but there's another way. No, just using algebra. Anybody know? Andrea?
You subbing y for
No? How about Noah? So let's think about it, Noah. If we're looking here, we want to know what is the input to get the same output. Okay? So what are we looking for? What are we trying to find? We're trying to find what? The input or the output? Right. We're trying to find the input. We want to know what do we have to input. Okay? So what does the input represent in these two equations? Right, the x value. Yeah, the x is the input. Good. It's the independent value. It's the x. So we want to find the x value when the y value is what?
0.
No. Not 0. David.
When the y value is the output.
Right, you're close. Santos. No, it's not a specific number. We don't know what the output is, right? But one thing we do know is we know, Daniel?
Are they the same?
Yes, we know they're the same. Okay? We want to find the output y when these two y values are the same. So what am I going to do? I'm going to set these two y values equal. Okay? So if we want to call this y1, and this is y2 for machine 2, I want to say, well, when y1 is equal to y2, what's x? Okay, make sense? So now I'm going to sub in my equation. So I have 1/2 x plus 0.75 is equal to y2 is x minus 0.5. Now, if I can solve this to find x, I'm going to know what my input is when my y value is the same. You guys get it? Okay, good. So I'm already in decimal here, so we'll just convert this one to decimal, even though I do prefer fractions, but this question started us off in decimal, so I'll just continue.
sir,
Yeah?
change the decimal to a fraction if you want to.
You could, yes. So, they're pretty easy decimals though, but if it was repeating decimals, I would definitely move to fractions. So the first step that I need to do here, anybody tell me? The first time you might have seen variables on both sides. Santos? Yeah, I gotta isolate x. Good. So when you're isolating, you have on both sides of the equality sign, of the equal sign, you're always gonna move them to the left. Okay? So the one that's already on the left, I'm gonna leave that there. But I want to bring this x over. So of course the sign is going to change to negative x. Okay? Now I want to move this away from my x's. So this was positive 0.75. It's going to move over to the other side. It's going to switch signs because of our inverse operation. So we're going to subtract 0.75 from both sides. So it disappears from this side. And it's over here now with a negative sign. Any questions there? I skipped a couple steps there. Michael? No? Can't talk. All right. So now I have 0.5 minus 1. What's that? Miguel? 0.5 minus 1.
0.5.
No? Minus 1.
Sorry. Negative 0.5.
Yes. Okay. Negative 0.5x is equal to 0.5 minus 0.7.